We are now in Unit 5, and we get to learn about functions. So previously we've been learning about linear equations. So let's say we had this linear equation, x plus 2 equals y. We're pretty familiar with the fact that we can choose numbers for x, plug them in, and find out what y is. So maybe I choose 0, 1, and 2. If I put those in, then I can figure out what the y is going to be. And obviously I would expect every single time I put in 0 into this equation, I would get 2 for y. And every single time I put in 2 for x, I should get 4 for y. This is what we consider a function, because every single time I put in something for x, I get that same thing out for y. There's another name for our x's and y's when we're talking about functions. Our x's are called inputs, and our y's are called outputs. And this makes sense because x is what we put in, so it's our input, and y is what comes out, so it's our output. So now let's get down the formal definition of our function. So a function is a special relationship where each input has a single output. So just like we saw, every time I put in 0, it has that one output of 2, or every time I have the input of 1, I have that one output of 3. And functions can be linear or nonlinear. I know we've been working a lot with linear equations, but now we're also going to start incorporate nonlinear things, because as long as there's an output for every input and a single output for every input, then it is considered a function. So let's also write down then what's not a function. So it's not a function if I have more than one output, a y, for every input. So if I put in 0 for the input, and that one time I get 2 and another time I get 5, that's not going to be a function. So you want to think about functions as consistency. So functions are always going to be consistent. I put in one number and I'm going to consistently get another number. I can consistently get a 4 if I put a 2 into this equation, and that's why it's a function. If I put a 2 into an equation and one time I get a 5 and one time I get a 7, it's not consistent, and therefore it's not a function. So let's take a look at sort of a real-life example of a function and not a function. So let's start by looking at why a soda machine is a function. Well, remember, a function means that for every input, there's only one output. So my input might be pushing one of these buttons. If I push the button for Coke, I'm going to expect that the output, of course, is going to be getting a Coke. Or if I push the button for 7-Up, I'm going to expect that I get a 7-Up coming out. So because I have that consistency of every single time I push that button, I'm going to get that output, it is considered a function. And in the same way, you can always have actually the same output for a couple of inputs. So sometimes there might be 2 buttons that are both marked for Coke, but I'm going to get that same output. So in the same way, I can put maybe a 2 and a 3 into an equation and both get out 5. And that's still considered a function because it's going to be consistent for those particular inputs. So I push the button for root beer and I get root beer. So that's a function. Slot machines, however, are not functions because they are not consistent. Our input is putting in the quarter, pulling the arm, and then you can get an array of things that can happen. You hit the jackpot, you get nothing, you get a couple things matching but not total. There is no consistency there. So this is not a function. So because it's not consistent, that outcome is always changing and we never know what's going to happen, this is not considered a function. Let's take a look at how to identify functions when we're given data. So here we have 3 different t-tables, and we're going to analyze based on the inputs and the outputs whether they are functions or not. So remember, each input should have its own consistent output. So let's take a look. So this first t-table, I put in a 1, I get a 2. I put in a 2, I get a 3. I put in a 1, and I get a 1. But last time I put in a 1, I got a 2. And then the next time they're saying I should get a 1. That doesn't make sense. I shouldn't have 2 different outputs. So this is not a function. So because I had 2 different outputs for the same input, One of the times I put in 1 and I got a 2, the other time I put in a 1 I get a 1, it's not going to be a function. Let's take a look at our next one. One of the times I put in a 1 I get a 1, I put in a 2 I get a 2, I put in a 3 and I get a 1. Now some of you may not be okay with that because you're thinking I should put in a 3 and get a 3, but that's not the definition of function. So maybe this is not linear, but that's okay. I have a single output for every input, so this is a function. Every input has one output. Every x has one y. Let's take a look at the last one. I put in a 1, I get a 2. I put in a 2, I get a 3. I put in a 1, I get a 2. So even though 1 pops up twice, because I'm consistently getting a 2, it's okay that it pops up twice. It's like having 2 buttons on a machine that say the same thing. It doesn't matter that there's 2 buttons for Pepsi. If I push both of them, I should expect to get a Pepsi, and that's okay. So here, this is still a function because I consistently am getting a 2 every time I put in a 1. So now let's take a look at identifying functions based on graphs. So here we have some lines. Both of them are not linear, but that's okay. They don't need to be linear. There's something specific you do to test whether or not a graph is linear or not, and it's called the vertical line test. What the vertical line test says is I should be able to draw a vertical line across the coordinate plane and only cross the graph once. So let's go ahead and try that out. If I draw a vertical line anywhere across this graph, it's only going to be hitting it once. No matter where I draw this vertical line, I'm only going to be crossing the graph one time. So this is a function. So this is a function because it passes the vertical line test. And realize what the vertical line test means. It means every x only has one y. So where x is 3, there's only one value for y. Or where x is 2, there's only one output, one value for y. Let's take a look at the next one. Let's try the vertical line test on this one. All right, that one looks okay. Only crosses once. Only crosses once. Only crosses once. Whoa, crosses 1, 2, 3 times? That doesn't work. Because what that means is where x is maybe, I don't know, maybe this is 2, y is equaling 1 and equaling 5 and equaling maybe -6. You can't have more than one output for every input. So this graph fails the vertical line test because when I drew this vertical line, it crossed the graph multiple places, and it should only cross once. So this is not a function. And that is it for your introduction to functions.